Well, welcome back. As you can see, I've come quite a ways since my last video with B2. In my last video, I had just barely gotten the electronics, the bare bones of the electronics working, and I got the drives going. But as you can see, I've made a tremendous amount of progress despite the lack of updates. So let me give you a quick tour of where he stands right now, and then take a little bit of a deeper dive into some of the cooler aspects of the build that I've had so far. Alright, so starting at the top, we've got the center part of B2's hat. You can tell it's the latest version because it has the embossed circle imprinted on it. The mounting parts for this, basically from this block on up, have been updated. So make sure you check the files, and if you printed the earlier version, you'll need to reprint a few files. You can tell the new version not only because of this here, but if we were to lift this off, you'll see that the mounting plate is actually a lot bigger than the previous one that was on there. So yeah, just make sure that you print the latest and greatest version of all the files. Below that, we've got his neck. This is nice because this easily fits in a single print. It's only a couple of walls thick, so it prints nice and quickly and prints really well. There are additional rings that are down on the lower body as well as the mid body, which isn't here right now. Those are printed in multiple pieces and need to be epoxied together, but they also print pretty easily. Moving over here, we've got this little greebly bit. This is not fully assembled yet, and it's printed in lots of different parts. This is the ideal piece to resin print if you happen to have a resin printer. But so far this has come out nicely, and once it's all painted and weathered, it'll look pretty good. The upper section has these four upper risers mounted to the bottom. These have already been primed and wet sanded. I'm going to give them another coat of primer before I put a final top coat of probably a dark metal, gunmetal or something similar for those. Inside here you see those 6 black arms. Those are the magnetic mount points. This entire upper body section is magnetically held in place, and in fact, if I can lift this off one-handed, there we go. You'll see these are the magnetic mount points there, and if we look over here, you've got the 6 magnetic points there. All right, so let's take a look at the lower level. So now that we've got the upper section off, you can see the bottom of the lower body pretty easily. Once again, we've got the ring here. This normally comes in 4 pieces. I ended up merging them in Prusa Slicer and then adding my own dovetails and printing these in hemispheres. Yeah, whichever way works for you is fine. These actually do go together pretty well, and these are held in place with 3 magnets as well as 3 sort of guide pins that position it in place really easily. Like the upper body, the lower body has 4 risers in there. This is actually kind of cool. The spacing gets a little bit tight. These are actually on a little compliant mechanism, which you can sort of see. In fact, I can take this ring out because this is also just held in magnetically. Put it down. You can see this little compliant mechanism. This is pretty cool. It's a print in place. See if I can get that to focus better. It's a print in place mechanism, and it just gives it a little bit of vertical movement capability. And going around the back, this is a modification that I made to the rear panel. I have my motor controllers behind here, and it's a little bit tight in there, and I wanted to make sure that there was some ventilation. So I did some pretty cool stuff in Prusa Slicer. Since I don't have access to the Fusion 360 files, Prusa Slicer allows you to import STLs as negative volumes. So I created a model in Fusion 360 of these slots and imported that and used that as the cutting volume for the existing part, and it was all done within the slicer, and it worked out beautifully, I think. So got a little bit of extra ventilation there. All right, so let's go ahead and take the body off, and I can show you what I've done on the inside. So just as an aside, when you're building a B2, you need a lot of space for parts. There's the lower body, there's the upper body with the ring that hasn't been installed yet. We've got B2's beautiful face, as well as his hat, so he's kind of spread all over the workshop at the moment. Let's take a look on the inside. So as I mentioned in my previous video, space is pretty limited. Looking at the back of B2, you can see where I've got the motor controllers nestled in the pocket to the rear. In front of that, I've got the Kyber board. Underneath that mess of wires is an 18-channel Maestro servo control board. In the middle there, that's the servo that operates the drive extension. Up here I have a voltage regulator that converts the 24 volt main bus voltage to 8.4 volts, which is what I use to operate the servos as well as the Kyber and the Maestro. And then in the front, underneath here, I'm using the same 40 amp breaker switch from Blue Seas that I used in R2D2. I was able to also use negative volumes in Prusa Slicer to cut holes in the print file for the switch itself. And that was relatively straightforward and easy to do. It is being powered by a 6-cell LiPo battery, and I have also installed some relays to cut power from the motors when the power is turned off. I've also got the RC receiver in there, and I think that about covers it. Let's talk a little bit about LiPo batteries. But before we do that, there's one more thing I did want to mention. This was just sort of an afterthought, but I was really glad that I did it. I actually found this extendable USB cable, and I have this connected directly into the Maestro. And this actually allows me to easily wheel him up in front of a PC and program the Maestro. The Kyber, conveniently enough, is actually Wi-Fi enabled, so it allows you to do over-the-air updates and configuration for that. So between that and the extendable USB cable, I should be able to make any updates to B2 that I need. So working on B2 has been my first exposure to LiPo batteries. I'm not going to lie, they kind of intimidate me a little bit because of the inherent danger in them. But given the space constraints on B2, there's simply no other alternative. So I have begun to dive down the LiPo battery rabbit hole, and I thought I would share at least a few of the basics that I've learned since I started this journey. First of all, the batteries themselves, the voltage is dictated by the number of cells. A 6-cell battery is what you use for 24 volts. That's basically the nominal voltage there. Fully charged, it's going to be a little bit more than that. And then the other thing to keep in mind is the C value. Now, honestly, for our needs, you really don't need anything that has a super high C value. The C basically tells you the fastest rate of safe discharge, and it's a multiplier of the actual battery capacity. So this is basically a 5 amp hour battery. A 50C means that it can safely discharge at 50 times its capacity, which is it could have a peak output of 250 amps. No one needs 250 amps. So really, if we're talking about batteries that have capacities in amp hours, anything more than 10 or 12 C is going to be fine, because we're not going to be pulling super high amperage for B2. So I wouldn't bother getting anything that's like a 60, 70, or 100 C battery. I'd rather you get the higher capacity. Although that being said, given the dimensions, this is about 40 by 45 centimeters. This is about the largest size that you can easily slide into the little chamber on the side of B2 without needing to take more things apart. So you might be able to get a little bit bigger than this. You might be able to find a 6 amp hour battery, but otherwise that's probably about what you're gonna deal with. And then the other thing is that the LiPo batteries are going to come with different types of connectors. So you just need to be aware that when you dive into LiPo batteries, you need to get a charger. you need to get a cable that connects the charger to your battery, and you need to make sure that they're all of the same connector type. So I just chose an XT90 connector, and then found out that the charger came with an XT60 output port. So I had to get an XT60 to XT90 adapter cable so I could connect the battery to it. In addition, a lot of LiPo chargers do not come with their own power supply. So this was a nice charger, and then I discovered it didn't actually come with a power supply. So had to get an external power supply as well. But you definitely want to get a good charger. This charger will also balance the batteries, which is important, balance the cells rather. It also can safely discharge them for storage for over long periods of time. You don't want to store a LiPo battery for extended periods of time fully charged. You want to discharge it to a safe voltage. And then there's also storage. So I also went ahead and got a fireproof container here. Also, as was recommended, several sources, something that is completely fireproof. So this is an ammo box, really cheap off of Amazon. So just don't mess around with these. And then finally, I also did get a voltage alarm. This actually connects to, I think this is called the balancing lead. This connects to the balancing lead, and it will set off a high-pitched squeal if the voltage gets below the safe voltage limit for LiPo batteries. So there's a fantastic website, DroneBotWorkshop. I'll put a link in the video description. I learned a lot just by watching his videos and reading his website. So LiPo batteries are no joke, but they are definitely the way to go for B2. So that's about what I've learned so far in a nutshell. I'm sure I'm going to be learning a lot more in the months to come. Let's talk a little bit about the Sabertooths. So in all, B2 has a total of 6 motors, one for each of the 4 drives, and then a motor for the upper ring and the lower ring inside the body. So these 6 motors then are divided between 3 of the Sabertooth 2x12 RC motor controllers. They're in many ways similar to the larger Sabertooths that we see on R2, except instead of signal wires, they essentially have RC servo connections that provide the signal. And then just like the larger Sabertooths, you've got one set of power connectors from the main power supply, in this case 24 volts, and then you have the output to each of the motors. Now these are completely configurable inside the Kyber software. Right now I have the left drive motor is controlled by one Sabertooth, and the right drive motor is controlled by another one. The one in the middle is going to operate both of the ring motors. But this is completely assignable, so if you decide you want to position your motor controllers elsewhere and maybe have one control both fronts and one control both rears, the Kyber software will allow you to assign all of those motors independently. The only thing that you do have to remember to do is in your dip switch settings, that first dip switch needs to be set to the down or off position. What that does is that enables independent control. If that dip switch is on or in the up position, then it's going to automatically apply mixing to both channels. So that's a key dip switch setting as well. The second dip switch is for exponential control. I find that keeping that in the down position also helps make him a little bit more controllable. And then the third dip switch in the down position is needed because I'm running lithium batteries. So that provides a safety cutoff if the voltage gets too low. So there is one more key modification that you need to make if you're going to use these motor controllers with the Kyber system, and that has to do with the servo leads. In a traditional RC setup, the intent of the Sabertooth is that it has an onboard voltage regulator that will provide a 5-volt output from the servo connectors, so that when you connect the Sabertooth to your RC receiver, the Sabertooth actually provides power to the receiver. It basically eliminates an extra component that you would otherwise have on your remote controlled item, whatever it happens to be. In this particular case, though, we're actually connecting this to a Maestro, and the Maestro already has voltage being provided to it. So we need to not provide voltage from the Sabertooth into the Maestro. And in order to do that, you need to modify these connectors. And what I did was remove the housing from the pins, and I simply cut back the red power connector. And then just to make sure that there were no shorts, I added some heat shrink tubing around that, so the red wire is cut off there. Now I actually also used a label maker that prints on heat shrink tubing, but that's really not necessary. But the key thing is you definitely want to remove that red power lead from the connectors before you connect this to your Maestro. So one of the other ways that B2 is a little bit different from R2 is in the use of relays. So this again comes back to the issue of regeneration current. I discussed that in my electronics build for R2. Now these motors that are used on B2 are pretty small. They only have a peak stall current of about 3 amps. So I don't know how much regeneration current is actually going to be produced by these if I push B2, but B2 is pretty heavy, and he's very awkward to pick up and lift. So in the interest of being better safe than sorry, I decided that this time I would actually employ relays on all of the drive motors rather than have separate cutoff switch or try and do a regeneration path back to the battery. And it actually worked out really well for this particular design because there are these little spots on each side, and I was able to find a double pole single throw relay that can operate 2 of the motors at the same time. So with the relay, you've got these 2 leads here that provide the power to the relay, and that's direct from the 24-volt bus. Now it doesn't matter which lead is positive and which one is negative, but you do need to install the flyback diode and have the band on the positive side. John Salt has a fantastic video from when he built his R2 where he really shows the importance of having the flyback diode, and that's to prevent backflow of high voltage spikes when the relay is energized. In his case, he hooked up an oscilloscope and it was able to show that there were voltage spikes in excess of 100 volts when you turn off the power. So that's important. And then it's pretty straightforward. This one actually just has the normally open terminals. So when the relay is not powered, i.e. when you turn the robot off, then that circuit is opened and those motors are isolated. I did use these cool little flag crimp connectors. Again, it's really just a matter of space saving. These were key to be able to get this to fit. Unfortunately, it does require a special crimper. Of course, that's always the case. But that was actually a lot simpler to implement than I thought. And then the relay itself is mounted on a cool little platform that I designed that fits right in there, and it actually attaches using the existing hardware that attaches the chassis to the metal frame. So then that brings us to the last little modification, and that is just the way that I approached installing these components. Again, space is limited, and the last thing I wanted to do was to start modifying the existing parts just to mount my electronics when I wasn't sure where they were going to be. What I ended up doing was designing my own little inserts, plates that were shaped according to either the forward or the aft section of the base there, and I could then model in whatever mounts I needed for the Maestro, the Kyber, my regulator, and so forth. These are some prototype versions that I had, and basically that's just modeled to fit in exactly into the spot. This hole here is uses the existing hardware that attaches the chassis to the frame. So this is simply a drop-in plate, and I can move these standoffs around if I want to. And in fact, I might need to in order to make room for the amplifier connection and so forth. So once everything is finalized, I'll make sure that all these things are available on my printables page. But for now, everything is still kind of in flux. So all that's super interesting, Jason, but what can he do? Well, let me show you a little bit about what he can do. So here's the electronic setup right now. I'm still working on getting the body lift servos working correctly, so I don't have any of the body on there. But the driving works as you would expect. Forward, back, you can spin in place, you can strafe left and right. all that works really well. And then what I've got set up is, I'm going to turn them around. So I've got this little switch on the side here that I can switch between his drive mode, and now it's in body lift mode. And so now when I use the sticks, he can actually tilt and lean from side to side. And it follows the stick just like you would expect. So I push forward and he dips his front down, and I lean back, leans back. So I can switch it back over to drive mode, and eventually there will be a mode where the two of them work in concert, so I can be driving, and as he drives forward he will dip down forward and so forth. So a lot of the configuration with Kyber comes down to getting the transmitter set up in a logical way, and I need to give some thought into how I want him to be configured as soon as I power him on. Do I want to be able to turn the head at the same time that I'm driving him, which is probably what I will do. So I might have the right stick operate the drives and the drive lifts, and I will have the left stick operate at least the turning and the tilting of the head. Each thing basically has an extra degree of freedom that I'm not sure how best to incorporate that, as I'm still somewhat new to RC. I'm not really quite sure exactly the best way to go about this, but one thing that I have learned over the last couple of weeks and months is that I really have a lot of flexibility with this system. I can set it up any way that I want. In fact, I've even made a lot of changes already, and just kind of rethinking the way that it's going to work. So that kind of the sky's the limit. So I think that kind of wraps up. I know there's a lot of information here. I didn't even really get into much of the body lift mechanism and stuff, but I'll save that for another video. Hopefully the update will be sooner rather than later. The next main thing is to get the body lift finalized, and I can get him all put together and then work on painting and finishing. So that's about it for this update. So thanks again for watching, and I'll talk to you next time.